Alrighty, everyone, welcome back. We're going to do examples 3 and 4. So we know that the lateral area of a cone is 77 pi millimeters squared. If the diameter is 14 millimeters, what is the slant height? Okay, let's go ahead. We're working backwards here a little bit. So to find the total surface area of a cone, we're doing pi r squared plus pi rl. Now, if you guys remember, this part that I'm highlighting in yellow, that's our base of our cone. So that's going to take care of the pi r squared. We know that this is going to be our lateral area. So like the top part of the cone here that I've just highlighted in green. So I know to find the lateral surface area of the cone, all I need is pi r l. I'm also given the lateral area of the cone. I'm told it's 77 pi. So what we're going to do is we're going to set 77 pi equal to pi r l, so equal to the formula. We know the diameter is 14. So if the diameter is 14, the radius is going to be half of that, or 7. So I'm going to have 77 pi equals pi times 7 times L, which is our slant height. Now I've got all of my variables filled in except for the slant height, but that's okay because that's what we're trying to find. That's what the problem is asking us to look for. So to get L by itself, I'm going to divide both sides by 7 pi. And what's nice is that our pi's cancel out, or they reduce to 1. And all I have to do is 77 divided by 7, or 11. So 11 is going to be our slant height. And if we're using units, it's going to be 11 millimeters. All right, let's go ahead and do example 4. So in example 4, we're looking for the total surface area of the solid. And it looks like I've got a cylinder on top of a cone. So I'm going to need the lateral surface area of my cylinder. So the lateral surface area of the cylinder is going to be this 2 pi RH. I'm going to need the lateral surface area of the cone, or just pi RL. And then I also just need this bottom base because that's also something that's going to be showing. So what I'm essentially doing is I'm finding the lateral surface area of the cylinder, adding it to the lateral surface area of the cone, adding it to the area of that bottom circle. So A, and then that little O just represents circle. So when I put all of these things together, all these pieces, I'm going to have 2 pi RH plus lateral surface area of the cone is pi RL plus pi r squared, because that's that bottom base. So here's the bottom base. Here's the part of the cylinder, and this is the part of the cone. Let's go ahead and start filling in things that we know. So I know that the radius is going to be half of 20, because 20 is the diameter. So that means the radius is 10. So anywhere I see an R, I'm going to put in a 10 because they all have the same radius. So 2 pi 10. Now that H is the height of the cylinder, which I know is 60. So I'm going to put 60 here, plus pi times 10 times L, or the slant height. So I don't know what the slant height is, but I do know that the height of the whole cone is 10. And I know that the radius is 10. So I've actually got an isosceles right triangle. And if you guys remember, that's a 45, 45, 90 right triangle. So the slant height is going to be 10 root 2. So the slant height, or L, is going to be 10 root 2 plus pi 10 squared. All right, let's go ahead and start simplifying. So let's see, 10 times 60 is 600, times 2 is 1200. So I have 1200 pi plus 100 root 2 times pi plus 100 pi. All right. And then when I go to combine like terms, I can really only combine the first term and the last term because the middle term has a root 2 and the others don't. So my final answer is going to look like 1300 pi plus 100 root 2 pi. And this is our total surface area of that solid shown.